Alright, we are going to continue in our chapter on demand. Now we're going to talk about the elasticity of demand. A little bit of math comes into our lesson today, but not too difficult. First of all, learning objective 1, compute the elasticity of demand and explain its relevance, and then we will discuss the factors that influence elasticity of demand. They're the determinants. Elasticity just talks about how sensitive a quantity demanded is to a change in price. So first of all, to compute the elasticity of demand, elasticity is another word for responsiveness. You'll need to know this for the test. Elasticity of demand measures the percent change in quantity demanded divided by the percent change in price. Elasticity of demand is percent change in quantity demanded over percent change in price. And we'll do an example here. If we just look at the demand for pizza, that fits just about perfect. And let's say that that might be too small, but we'll see how it works. Pizza, the price per pizza changes from $12, let's see if we can do this, to $9. And with that shift, we went from $12 to $9. So at $12, we're at 14, I believe that's million pizzas per week. 14 to, and at $9, we're at 20. So price per pizza, so up here it's going to be our price, and down here it's going to be our quantity. That's just a number, not a hashtag or a pound. So to do percent change of quantity over percent change in price, we would do 14 minus 20. I'm going to put that in parentheses for those of you that are paying attention. Sorry, it's a difference, not in the right order. So 20 minus 14, and then we're going to divide by our first number. So I always write it in the right order. So at $12 to $9, our quantity goes from 14 to 20. So difference in the quantity divided by the bigger number. And that is 14, or 20 minus 14 is 6. Divided by 20, I get 0.3. Or 33%. And then our price is difference in price divided by the first number. 12 minus 9 is 3, divided by 12. I did that wrong. 0.25. Cool. All right. I'm going to move this for a second. I'll bring it right back. I'm going to move this also. We are going to go backwards. Percent change in quantity demanded divided by the percent change in price. So the first calculation we did was the percent change in quantity demanded, so 33 divided by the percent change in price, which is 25. So our elasticity equals 1.32. What does that mean? I'll tell you. When your elasticity value is greater than 1, your demand is considered elastic. The quantity demanded is relatively responsive to a change in price. When your elasticity value is 1, the demand is unit elastic. The quantity demanded just equals the percent change in price. And then your elasticity value is less than 1, demand is considered inelastic. So your quantity demanded is relatively unresponsive to a change in price. Demand is almost always more elastic at higher prices and less elastic at lower prices. You'll need to know this also. Actually, all of this, but this is a question you'll see again. All right, let's look at these fries. Mel decided to lower the price of his fries from $1 per serving to 75 cents, a 25% change in price. As a result, the quantity of fries demanded increased from 75 to 150 servings per day, a 100% change in the quantity demanded. The elasticity of demand, oh, it's right there, is 4, which is 100. 100% divided by 25% is 4. This is actually incorrect. I'll have to change that later. So it's 100 divided by 25, which is 4. A value of 4 indicates demand is quite elastic. Products that are easily substituted, such as fries, almost always have demand that is elastic. And then insulin, another example. Demand for insulin that's used to control diabetes. If the price of a month's supply of this medication decreased from $20 to $15, which is a 25% decrease, the amount purchased might increase by only 1% because people who need this drug are already buying it at a price of $20. So basically, people who don't need the drug aren't going to go buy it just because it's on sale. It's not a substitution for anything. And then people who are currently buying it can't exactly stock up on it because it has an expiration date. So the new lower price would not cause them to buy or cause other people who do not need the drug to purchase it. In this case, the elasticity of demand would be 0.04. A value of 0.04 indicates demand that is very inelastic. Products that are necessary and cannot be substituted, such as insulin, almost always have demand that is inelastic. There we go. Elasticity and total revenue. If you remember revenue, the total revenue is the price multiplied by the quantity demanded at that price. So if they sell, 10 fries and the price is $10, the total revenue is $100. Elasticity also indicates how a price change affects total revenue. And total revenue is the price multiplied by the quantity demanded at that price. Think about it. Lower price means producers are paid less for each unit sold, which tends to decrease total revenue. According to the law of demand, a lower price increases quantity demanded, which tends to increase total revenue. The impact of lower price on total revenue can be estimated using the elasticity of demand. So if elasticity is greater than 1, you're elastic, and then your total revenue should increase. If elasticity is equal to 1, it's unit elastic, and your total revenue should remain unchanged. And then when your elasticity is less than 1, it's inelastic, and your total revenue falls. And let's look at the fries. Remember, at a price of $1, Mel sold 75 servings per day. His total revenue from the sales was $75. $1 times 75 units is $75. After he lowered his price of the fries to 75 cents, his sales grew to 150. And his revenue increased. 75 cents times 150 is $112.50. So this is an elastic product. When the price is lowered, its total revenue grew. But then insulin, remember this is inelastic. So this will show you when the price falls, the total revenue is actually going to fall too. So let's say a drugstore sold 1,000 vials per month at $20 each. The store's total revenue at that price was $20,000. When the price was lowered to $15, the quantity sold increased by 1% to 1,010 units. The store's total revenue fell to $15,150. When the price of a product with inelastic demand is lowered, its total revenue will fall also. Okay, let's talk about the determinants of demand elasticity. We haven't considered why elasticity differs for different goods. Several characteristics influence the elasticity of demand. First of all, ability of substitutes. The greater the availability of substitutes for a good, the more similar these are to the good in question, the greater that's good elasticity of demand. So if there are substitutes available, then your good is more elastic. The more broadly a good is defined, the fewer substitutes there are, and the less elastic the demand. Everyone needs shoes, so the demand for shoes in general tends to be inelastic. Let's see. If the shoe prices go up 20%, most people will still buy shoes. Eventually, they may wait a little bit longer, but they're still going to buy shoes because we all need shoes. If you consider one particular brand of shoes, however, the demand will be more elastic because there are many other brands of shoes you could buy instead. For example, if only one shoe manufacturer raises its price by 20%, many shoe buyers will switch to other brands, which have not increased in price. But on the other side, certain goods, like prescription drugs, have no close substitutes. So the demand for such goods tends to be less elastic than for goods with close substitutes, such as Bayer aspirin. I don't even know if you know what Bayer aspirin is, but Bayer is a brand of aspirin. But much advertising is aimed at establishing in the customer's mind the uniqueness of a particular product, in an effort to convince consumers to accept no substitutes. So Bayer spends a lot of money in advertising to make you brand loyal. So you won't walk into Walmart and buy Great Value brand aspirin. You'll want to buy the brand name. But prescription drugs have no substitutes, so they are pretty inelastic. Aspirin has a lot of substitutes, so they're pretty elastic, or ibuprofen. You know, we have Advil and we have store brands. Share of the consumer's budget spent on the good. Higher prices reduce the quantity demanded, in part because a higher price lowers the real spending power of consumer income. A demand curve reflects both the consumer's willingness and ability to purchase a good at alternative prices. The more important the item is as a share of the consumer's budget, other things constant, the greater is the income effect of a change in price. So the more elastic is for the demand of the item. So let's talk about that for a second. An increase in the price of housing, for example, reduces the ability to purchase housing because houses take up such a large part of our budget. The income effect of a higher price reduces the quantity demanded. In contrast, the income effect of an increase in the price of paper towels is smaller. It's very insignificant because paper towels represent such a tiny share of our budget. The more important the item is as a share of our budget, the greater is the income effect of a change in price. So the more elastic is the demand for the item. This is why the quantity of housing demanded is more responsive to a price change than the quantity of paper towels demanded. We buy paper towels no matter what. We may put off buying a house if housing prices go up. Duration of the adjustment period. The longer the adjustment period, the easier it is to find lower price substitutes. The longer the period of adjustment, the more responsive the change in quantity demanded is to a given price. So let's tell a story about gas price or oil prices, which affect gas. In 1973-74, price of oil rose by 45%. That's a huge increase. The quantity demanded only fell by 8%. That's strange. You would think if the prices rose that much, the quantity demanded would fall that much. But as time passed, people purchased smaller cars and used public transportation. Oil generates electricity and heats homes, so people would buy more efficient appliances and they'd insulate their homes better. So over time, the quantity demanded decreased more. So in the short run, we were not able to affect our demand when prices increased so much because we were stuck. We had what we had. We had our car that we had our house that we had. But over time, we found ways to get around, to get away from using so much oil. We're going to skip that. All right, let's talk about, which one? No. How about this one? How many staples do you use in a typical week at school? Probably not many. Do you think your demand for staples is, oh, that says staples, that's funny. Staples is elastic or inelastic? So if we talk about it, a box of staples, a box of 5,000 staples is pretty common. If you go into a store, you can buy a box of thousands of staples. So one single staple is likely to be as little as 0.0001 cent. Would you use fewer staples if the price doubled? Probably not. The demand for staples is inelastic because the price is so small. A 100% increase is insignificant and will have little to no impact on the quantity demanded. This can be said for any product that has very low price and therefore constitutes a small part of a consumer's total budget. Higher priced items are more elastic. Yeah. All right, let's talk about elasticity estimates. Switching to lower price substitutes usually takes time. This is the short run versus the long run. In the short run, it's a period which consumers have little time to adjust to a price change. That's like the gasoline example that we just talked about. In the long run, it's a period which consumers can more fully adjust to a price change. So in the long run, we can make changes to our lives because of a price change in a product. The elasticity of demand is greater in the long run because consumers have more time to adjust. You'll need to remember that. If we look at these examples, electricity. If electricity increased dramatically, in the short run, our usage doesn't change much, but in the long run, it does. Okay, these are elasticity numbers. So in the short run, our elasticity is very inelastic. In the long run, it's elastic. Air travel. If air prices, like if airline raise their prices dramatically in the next few weeks, we're all stuck. We're going on spring break. We need to buy plane tickets. So in the short run, very inelastic. But in the long run, we may decide to drive. Gasoline. In the short run, if gas prices go up, we're very inelastic. But in the long run, we can change our behavior, drive less, carpool, ride share, or even, work our errands into fewer trips. So in the long run, it becomes more elastic. This video is on your playlist. And I believe that is it for 4.2.